point in the graph of the parabola y is equal to f of x, which is equal to x squared minus 4x plus 5, where the slope is 0. Basically, so the slope is horizontal, or we've got a flat line, or a minimum or a maximum of the function. Find that point using A, the derivative, and B, a little bit of algebra. So what I've done is I've graphed out that function. So this right here is x squared minus 4x plus 5. That's this graph right here. And clearly you can tell down here at the bottom that if I were to draw out the tangent line, close enough, to that point, it would be flat. It would be horizontal, and so that's the place that we're looking for. Now, if you look here at the graph, it looks like it occurs at an x value of 2. Now, we're going to go ahead and show that it does actually occur at the x value of 2 using using both a little bit of calculus with the derivative and then also using some algebra that you're familiar with. Okay, so to get started, let's go ahead with the calculus part of it. Well, we need to find an equation that gives us the slope of the tangent line, and guess what? That equation is this f prime, or the derivative, so the slope of the tangent line. And then what we're going to do is we're going to set that guy equal to 0, because we want to know what x value gives a slope that's 0. So first we need to find f prime as a function of whatever we stick in here. Okay, so that's not too hard to do. There's two ways we can do it. We can use that quadratic rule that we did before, or we can do it the long way. I'm going to do the long way again because it's important that you are familiar with that, because you're going to need to be able to do it for the exam. However, we'll start to use these rules as we progress through the chapter. So what do we need? Well, we need to calculate f at something plus a little bit minus f at that same something over a little bit. Okay, so we're going to go through here, and I'm going to plug these guys in to my function here. So that's a little bit, or something plus a little bit squared. Okay, that's excuse me, not squared. The whole thing's got to be squared. Okay, that's this guy right here. Oh, excuse me, that's this guy right here being plugged in right here. So minus 4 times that same thing. Okay, plus 5. So what do I have there? This right here is this right here. Okay. Notice I didn't even plug in. We had been using x naught to plug in there. I'm just using the box. There's nothing wrong with it. It's a placeholder. It's a spot for your variable. So I can put whatever I want to put in there. If you want to put a smiley face, put a smiley face. So now we're going to subtract f of the box, which is the box squared minus 4 times the box plus 5. And we're going to divide that whole thing by delta x. So what does this give us? That gives us this guy right here squared plus this guy times 2. So 2 times the box times delta x plus delta x squared minus 4 boxes minus 4 delta x plus 5 minus the box squared plus 4 boxes minus 5. I don't know if you can still see that over there on the edge, over delta x. I'll move it over just a little bit. So what cancels out? Well, the boxes squared cancel out, the negative 4 box and the positive 4 box, and the 5 and the negative 5 cancel out. So what do we have? We've got 2 box delta x plus delta x squared minus 4 delta x over delta x, which reduces to 2 box, minus, so 2 box minus 4. That's exactly what we would have found had we used that formula before, which says that, so remember, this is f prime of something, derivative of something, is equal to 2 times that something minus 4. That's the same thing we would have gotten had we used the formula for delta x, or excuse me, x naught of f prime, or f prime, excuse me, f prime of x naught, which would give us 2a x naught plus b. Well, my a value is 1, and my b value was negative 4. So what is this? I like it. They're the same guy, right? Whatever I plug in here goes here. Whatever I plug in here goes here. Same exact thing, okay? So, what does that tell me? Well, what I need to know is what do I plug in to get the slope to be 0, right? Because this equation is the slope of the tangent line. Well, I want the slope, the m value here, to be 0. And this right here is the m value. So we need to solve this. Well, what do we have to plug in here to get 0 out? Well, it's pretty easy. If you plug in a 2 here, you get 0 out. Watch. 2 times 2 minus 4. Look at that. It's equal to 0. So that tells us algebraically that when x is equal to 2, okay, the tangent line is flat. It's horizontal. That's going to be important later when we're trying to find the minimum of a function, or maybe the maximum of a function. Okay, so we're looking at the behavior of the function and what's going on. Now, how do you do it algebraically? Well, we've done that before in past classes. We've got a parabola, right? Okay, so the algebra portion. So this is B. Well, the algebra says, look, if you've got x squared, minus 4x plus 5, and you want to know when this guy is at a peak or a valley, a top or bottom, what are you looking for? Well, you're looking for its vertex. So you guys already know that to find the vertex, you take negative b and divide it by 2a. So negative b is positive 4 divided by 2 times 1. Look at that. We get the number 2 out. Do you know where this thing comes from right here? This thing comes from this thing right here. Look, if 2ax naught plus b, if you want the slope to be equal to 0, watch. Move the b over, and now divide by 2a. And so x naught is equal to negative b over 2a. Check that out. So now you know exactly where that formula for the vertex came from. Now the book does so by completing the square and showing how you could translate the function, moving it around on the graph. And I think you should read through that as well. But this is a nice little algebraic way of determining it as well.